Welcome, my dear sixth grade students. I'm Mr. Ahmed Magdy, my teacher. Our lessons today are the third lesson of the seventh unit of the sixth grade curriculum for the academic year 2024-2025, and this unit talks about measures of central tendency and spread. Today we will talk about the meaning of the median, mean, outliers, then how to determine how outlier and shapes of a graph can help to determine whether mean or median is better measure for center. So let's go. Our first part here in our lesson is about what is the meaning of mean and median and mode. We discovered the rule of mean in the previous lesson, and now we will talk about it in more advanced way. And the median is a measurement of central tendency that makes us get the number or the data that it's inside or in the middle of this data set. And the mode is a measure that helps us to get the value that repeats most in our data set. Again, first, the mode. What is the meaning of the mode? The mode is the value that occurs most often. So, if I have an example like this, I have 5, 3, 8, 9, 8, and 12. I see that 8 repeated 2 times, so I can say that the mode is 8. Here, I have 3, 7, 2, 7, 3, 8. I see that 3 is repeated 2 times and 7 repeated 2 times. So I can say that I have 2 modes, 7 and 3. So I can call it a bi-model dataset. Okay? Here I have 15, 16, 9, 8, 11. I think I have no mode because I don't see any value that occurs most often, because every value is repeated just one time. So I think there is no mode for all values because all values are different. And if I wanted to find the mode in a data set that represented by a dot plot, I will search about the value that repeated most times. So I have here, in this example, I have 30 repeated 5 times, and 50 repeated 6 times, and 60 repeated 3 times, 70 repeated 2 times, and 80 repeated 1 time. So I think 50 is the mode of our data set because 50 is repeated most times and more than any other value. So I can say that the mode is 50 because it has the greatest frequency. Okay? Number 2, or the second part, is about what is the meaning of layer or outlier. Outliers are values that lie outside, or maybe I can call it is much smaller than or much greater than most of the other values in a set of data. So, and when I have example like this, I have 24, 23, 7, 28, 26, 29. I think 7 here is different about most of the values here because I have 24, 23, 28, 26, 29. I think all of these is 20s. So I think 7 is much smaller than other values, so I can call it the outlier of the data set. So the outlier here is 7. Here in the dot plot graph, when you see most of the dots grouped in one area, and I have one dot is far away or lie outside this group, so I can say this dot is the outlier. So I can call it the outlier of the data set. So the outlier here is 10. Okay. Here I wanted to find the mean, the mode, the median, and the outliers for every dataset or every dot plot. The first one here, I have 19, 3, 5, 7, 4, 5, 6. First, before anything, you must rearrange these values ascendingly from the least value to the greatest value. So, I think the least one here is 3. Next, I have 4, 5, 5 again, 6, 7, and I have 19. So, first, I wanted to find the mean. In the previous lesson, we talked about the mean, and we have one rule to find the mean of set of data. So, what can I do? I will add them together, and I will divide the total or the sum by the number of values. So I have 3 plus 4 plus 5 plus 5 plus 6 plus 7 plus 19. So I have 1, 2, 3, 4, 5, 6, 7 values. So I would divide them over 7. So I have 3 plus 4 plus 5 plus 5 equals 17. 17 plus 6 equals 23. And 23 plus 7 equals 30. And 30 plus 19 equals 49. So I have 49 divided by 7. So the mean will be 7. Okay? So if I wanted to find the median, I will arrange them first ascendingly, and I will find the number that lies in the middle of this data set. So I have 1, 2, 3, 4, 5, 6, 7. So I think the fourth value will be the median. So I have 5. So the median will be 5. Next, I have the mode. The mode here is the value that occurs most often. So I have 5 repeated 2 times. So I will say mode equals 5. Next, I have the outlier. Outlier here, that the value that is more or much greater than otherwise or much smaller than otherwise. But here I have 19, and 19 is much bigger than other values. So I can say that 19 is the outlier of this dataset. Next, I have a dot plot, and I want to find the mean, the median, the mode, and the outlier of this dot plot or this dataset. So first, I wanted to find the mean. So I will find the sum of all of these values, and I will divide them by the number of these values. So I have, here I have 2 4s, so I can say 4 plus 4. Next I have 1, 2, 3, 4 6s, so I have 6 plus 6 plus 6 plus 6. And next I have 3 8s, so I will say 8 plus 8 plus 8. And finally I have 1 time of 16, so I can say plus 16. And all of these divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I would divide them by 10. The total here will be 72. So 72 divided by 10 will be equal to 7.2. And this is the mean of this value. Next, I want to find the median and the mode. So the median here, I will arrange them first to find the median. I think I arranged them like this. I have 4, 4, 6, 6, 6, 6, 8, 8, 8, and 16. I have 10 values, so I have two medians. So I have 6 and 6. So I will say 6 plus 6 over 2. So it will be 12 over 2 equals the 6. So the median equals the 6. Next, I have the mode. What is the value that occurs very often? So I have 4 6s. So I will say the mode is equal to 6. Next, I have the outlier. Where is the outlier? I think here I have 16 lies outside the group of dots. So I will say that outlier here is equal to 16. Next, I have this example. I wanted to find the mean, median, mode, and outlier for this data set. So I have 1, 1, 2, 3, 5, and 12. So first, I wanted to find the mean. Here, I will add them together and divide them by 1, 2, 3, 4, 5, 6. So I will say 1 plus 1 plus 2 plus 3 plus 5 plus 12. And now all of these divided by 6. So I have 2 plus 2 equals 4 plus 3 equals 7. 7 plus 5 equals 12. And 12 plus 12 equals 24. So I have 24 divided by 6. 24 divided by 6 equals 4. So the mean is equal to 4. Next, I wanted to find the mode. What is the value that occurs most often? I think it's 1. So I will say the mode is 1. Next, I wanted to find the median. First, I wanted to arrange them. And for my luck, I think it's arranged. So they are arranged. So I will say that I have 1, 2, 3, 4, 5, 6 values. So I have two medians. I have 2 and 3. So I will say the median is equal to 2 plus 3 over 2. So it will be 5 over 2 equals 2.5. Okay. And the last one is the outlier. Where is the outlier? I think I have 1, 1, 2, 3, 5, and 12. I think 12 is much bigger than other values. So I will say is 12. The outlier is 12. Next, I want to know how the outlier affects the median and the mean of most of data sets. Okay, so I have an example like this. I have quiz scores. I have 5, 88, 90, 93, and 94. Here I have one outlier, and this outlier is 5 because 5 is much smaller or much less than other values. So I will say if I have an outlier and if I don't have the outlier, what will happen? With the outlier, if I wanted to find the median here will be 90. But here, without the outlier, I will find that I have two medians, so I would add them and divide it by 2, so it will be 91.5. So here I have 90 and here I have 91.5, so the outlier has weak effect on the median. So I think the difference between the two numbers is very small. So I think we don't have any effect, but we can say that it has weak effect on the median. But we will know, or we will say something about this. If the outlier values are smaller than the other values, the outlier decreases the median. Again, if the outlier is smaller, the outlier will decrease the median. If the outlier is greater than other values, I will say that the outlier will increase the mean. Okay? So I wanted to find if the outlier has a weak effect or great effect on the mean. So I said that the outlier has a weak effect on the median, but what about the mean? If I wanted to find the mean with the outlier and without the outlier, with the outlier it will be 74 because 5 plus 88 plus 90 plus 93 plus 94 equals 370, and I would divide it by 4, so it will be 74. Okay, but without the outlier the mean will be 91.25. The difference here between the two means is very big, so I will say that the outlier has great effect on the mean. So the outlier has weak effect on the median but has great effect on the mean. So which measure of central tendency we can use on dataset if we have outlier or if we have no outlier? If we have an outlier, we will use the median because the median will not be affected very much by the outlier. But if we don't have an outlier, we will use the mean to find the measure of central tendency. So I have an example like this. I wanted to find the mean including outlier and without outlier. Okay, the first one here I have 5, 20, 25, 35 and 30. So first I wanted to find the mean without the outlier, so I will cancel the 5 because 5 here is the outlier of this data set because 5 is much smaller than other values. So I will say 20 plus 25 plus 35 plus 30 equals what? Equals 110. So 110 divided 4 will be 27.5, and this is the mean without the outlier. But if I wanted to find the mean including the outlier, it will be 23. So I think the small outlier decreases the mean. The small outlier decreases the mean. So if I want to say what about the big outlier, I think it will increase the mean. So let's try another example. So I have 10, 15, 15, 20 and 80. I have an outlier right here. I have 80, and 80 here is a big outlier. So what will happen to the mean? So if I wanted to find the mean without the outlier first, so I will say mean without outlier. So it will be 10 plus 15 plus 15 plus 20, and all of these divided by 4. So 10 plus 20 equals 30, and 15 plus 15 equals 30. So 30 plus 30 equals 60, and 60 divided 4 equals 15. So this is the outlier. This is the mean without the outlier. Okay, so I wanted to find the mean with outlier or including outlier. Okay, so it will be 10 plus 15 plus 15 plus 20 plus 80, and all of these divided by 5. So I have 60. 60 plus 80 equals 140. 140 divided 4 divided 5 equals 28. So do you notice the difference between the two numbers? I have the mean without the outlier equals 15, and the mean with outlier or including the outlier is 28. So the difference is very big, and the outlier is now bigger with outlier. So I can say the outlier here increases the mean. So the great outlier increases the mean. Okay, I have another one. I have 2, 5, 1, 3, 3, 5, 2, 20, 20, 20. I have 3 outliers because 20 is much bigger than other values. So I have 3 outliers. So first I will find the mean without outlier. So it will be 2 plus 5 plus 1 plus 3 plus 3 plus 5 plus 2, and all of these divided by 1, 2, 3, 4, 5, 6, 7. So divided by 7. So 2 plus 5 plus 1 equals 8. 8 plus 3 equals 11. 11 plus 3 equals 14. And 14 plus 7 equals 21. So it will be 21 divided by 7. So the outlier will be, or the mean will be, equal to 3. Okay. Next, I wanted to find the mean including the outlier. Okay. So I have 2 plus 5 plus 1 plus 3 plus 3 plus 5 plus 2 plus 20 plus 20 plus 20. So, and all of these divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 divided by 10. So I have 21, and plus 20 plus 20 plus 20 equals 81. And 81 divided by 10 is equal to 8.1. So I have 3 and 8.1. So I think the great outliers increases the mean. So this is like this because I have a greater outlier and the mean will increase. Okay, so look again. Here I have dot plots. The first one has only one outlier value, and the second one has 5 outliers values. So the outlier here has a small effect on the mean. Because I have only one value. Okay, but here I have 5 outliers. So the outliers have great effect on the mean. Here it will increase the mean. It will increase the mean with great effect, but here it will decrease the mean but with small effect. Okay, so I have many different dot plots or different shapes of dot plots. Okay, so maybe the dot plots will be distributed in one side of the graph. So what is the best measure for central tendency for this dot plot? The mean or the median? So in the first type of shapes or types of dot plots, if the dot plots are distributed in one side of the graph, the median is better for central tendency or measuring central tendency. Here, if the dot plots are distributed symmetrically on the graph with the symmetrical shape, I think we can use mean or median because they have the same effect. But if the dot plots are distributed evenly on the two sides on the graph without symmetry, I think the mean is better. But don't forget, if you have an outlier, the median is better. So if we have graphs like this and I want to choose the measure of central tendency, you think will be better to use? The first one here, I have a dot plot, but it distributed in one side of the graph. So what is the best way to measure the central tendency? Again, let's remember, if we have the dot plots are distributed in one side of the graph, the median is better. If we have a symmetrically shape on the graph, mean or median is equal. Okay, and if we don't have a symmetrically or one side distribution, we can use the mean. So here I have one side, so I will choose the median. Here I have an outlier, and I told you if you have an outlier, the median is better, so I will choose the median. Here I think we have symmetrically shape on the dot plot, so I will choose either because we can use the mean or the median. Okay, next I have a distribution evenly on the two sides, so I think it will be the median, the better way. Okay, now I want to answer this question to review all the lesson in one page. The first question here, I want to select the outlier in this data set. I have 22, 27, 25, 24, 26, 23, 99, 22, 25. I think it will be 20. I think it will be 99. Okay, so the outlier will be 99. Okay, choose the best description of the mean if the outlier has been removed according to the following graph. I think here the following graph has a small outlier, so the mean will increase, the mean will decrease, or the mean will stay the same. Again, I want to find the best description of the mean if the outlier has been removed. So here in the original graph, the mean will be smaller. But if we want to remove it, I think the mean will increase because we will not have an outlier. Okay. Next, I wanted to choose the best measure of central tendency I think to use. I have here this shape. I think it's symmetrically shaped. So I think either median or mean is the way to use or the way to measure the central tendency. So I think I will choose either. Next, I wanted to find the mood. So what is the value that occurs most often? So I have 2, 2, 2, 2. I have 4 twos, okay? And I have 1 4, 1 4, 1 4, yeah, or 3 fours. I have 1 5, 2 fives. I have 1 6 and 1 7. So I think 2 is the mood of the data set. So it will be 2. So with this, we have finished our video today, in which we talked about the meaning of median, mean, outlier, and mood. Then how to determine how outliers and shapes of the graph can help to determine whether mean or median is better measure for central tendency. I hope understand. I hope you understand. I hope people understand our lesson today, and I hope that you solve many exercises on this lesson so that you can understand more. If you have any questions, leave them in the comments. Don't forget to like and share the video with your friends. Subscribe to my channel. I see you soon in a new video and a new lesson. I'm Mr. Ahmed Magdy, your math teacher. Goodbye.